Marketers from a well-known toothpaste company are interested in brand loyalty for two different age groups, those under 30 and those 30 or older. Study participants were those who had indicated they always buy the same brand of toothpaste. Participants were asked, if another brand offered you a similar type of toothpaste for a 10% discount, would you switch brands? Out of 300 respondents under 30, 162 said yes. Out of 240 respondents who were 30 or older, 115 said yes. We want a 99% confidence interval for the difference in the proportions of those who would switch brands for the two age groups. And then we want to comment on what it would say when comparing those two populations. Okay, so to start off, we have the group under 30, and 162 out of 300 of them responded yes to this question. So our proportion from our sample for group 1, which we call P1 hat, is 162 divided by 300, and that's equal to 0.54. For group 2, we have 115 out of 240 who responded yes, and that'll give us a proportion of 0.4792. So our confidence interval starts with the difference in our sample values, 0.54 minus 0.4792, and then we add or subtract our z-value. When doing a 99% confidence interval, the z that we use is 2.575. Our standard error under the square root gives us our P1 hat times 1 minus P1 hat over the sample size, which here is 300, plus P2 hat of 0.4792 times 1 minus that over that sample size, which is equal to 240. So what we will find here is that we get an interval that has a lower bound of negative 0.0505 and an upper bound of 0.1721. And this is a 99% confidence interval for our difference in population proportions, so for P1 minus P2. If we looked at all people at these certain age groups who use this toothpaste and how many would switch to a different toothpaste, this captures that difference in proportions. So looking at this interval, what we see is that the lower bound is a negative quantity, the upper bound is a positive quantity. When we have a negative and a positive, what that means is that 0 is in this interval. And so this quantity, P1 minus P2, it could be equal to 0. And if P1 minus P2 equal to 0 is possible, what that is saying is that if the difference is 0, that P1 equal to P2 is possible. So in this case, we're not able to say that there's a difference in these two groups because it's possible that the two proportions are actually the same. So at the 99% level, the level that we did the interval at, there is no difference in the population proportions of people who would switch toothpaste for the two age groups. So we cannot say that we'd have a difference here if we were able to look at the whole population and calculate the proportion for each group. The conditions that you need to check here for your confidence interval to be valid is that each of your n's times its p hat is greater than 5, and each of your n's times 1 minus p hat is greater than 5. So you would check here your p hat of 0.54 and 1 minus 0.54. If you take each of those times the n for that group, 300, those need to be greater than or equal to 5, which you can see that would be true here. And then you also want to check that for group 2 and make sure that that's also verified.